Hello guys, welcome to continue our session. Okay, let's solve revision sheet 2 during this session. Let's start with the first question. Here, as you see, what is the head of the question? I have to read the head of the question well to know how to solve. Here, as you see, use look with me here, use the function g of x defined and grabbed below to answer the following question. That is the graph of the function, okay, and what is the rule? That is the rule of the function. Here he asks you, does g of 1 exist? As you see here is what? 1. I'm asking about the g of 1 defined or undefined, or it has value or no. As you see, I have to look at 1. Do you have any bold? Yes, here that is a bold point. Its value -1. G of 1 is what? -2. Sorry, g of 1 equal -2. But here he asks you, does g of 1 exist? We have to write what? Yes. Okay, for the second question, does the limit g of x when x approaches 1 exist? As you see here, as we approach it to 1 from right, go with the curve until we reach maybe above, below, or at 1. But here we reach at 1, take the value of y, it will be what? 0. So the limit from right 0, the limit from left is what? 0. Since the behavior of the function from left as the behavior of the function from right, so the limit exists, and we write yes. Okay, I think it's easy. Let's see the next question. Look with me here. Does limit g of x equal limit g of x here? Until we take the pen, I'm sorry because I have to change from mouse to pen. As you see here, does limit g of x when x approaches 1 equal g of 1? You have to look at the, clear everything first. A limit equal what? As I told you before, the limit of g of x equal 0 when x approaches 1. G of 1, it will be -2 as we solved in the session. Since the limit not equal g of 1, I would say what? No. Here is g continuous at x equal 1 by looking at the curve as you see here. Here as you see, we have what? Gap. It is one of the case at which is the function not continuous. So I will write here what? No. Clear? By another way, we can use a graph to answer. But as I told you before, function continuous at a value of x if it satisfies 3 conditions. The first one, what? The function exists or defined at least. The second one, limit exists. Third step, the limit must be equal the value of the function at this point. But the third condition not satisfied, because I told you before, if we have only one condition unsatisfied, so the function will not be continuous. Clear first, then let's solve the next one. Okay, our mouse. Here, what is the next question? Is g defined at x equal -1? As you see here, look with me, as you see at -1, at what? As you see at -1, where is -1 miss? Here, that is -1. At -1, we have only what? Whole. So the function undefined at x equal -1 because it has whole. There is no any bold. There is no continuous line at x equal -1. If we have whole only, it means the function undefined. Is g continuous at x equal -1? I think it's so clear from the graph. At x equal -1, the function has what? It has only whole. It has only what? As you see here, look with me. It has only what? Whole. So in this case, we write it does not, sorry, it is not continuous. We write here what? No. And here's a function defined at 1, at -1, no. Okay, I think it's clear now. Let's solve the next question. The last question here, he asks you what? For what values of x is g continuous? Okay, again, I'm so sorry because I have to go up and down to show you the curve of the function. Clear first. Then let's solve. Here, as I told you before, look at the curve of the function with me here. Look, the function, the line of the curve of the function is continuous. There is no any interruption. So here, from at -2, not continuous, at -1 continuous because it has what? Whole. So the first, when we are talking about all of the real number between -1 and between -2 and -1, we use interval. Here we have to write. Since -2 not included, I use this arc as I explained before. -2, -1. Okay. Here the curve of the function, as you see, continuous. There is no any interruption here. Okay, between what and what, as we solved in the session also. -1, 0. -1 not included, 0 not included because the function at -1 and 0 is not continuous. Here on this curve between 0 and 1, okay, we will write what? 0 and 1. The function is continuous, but since it is open because they are not continuous at 1 and at 0, I write open interval. Here from 1 to 2, but at 2 also, at 2 continuous. I don't have an interruption at 2. So we will write what here? Open into semi open interval like this one at 1 and 2 closed because at 2 the function, as you see, continuous. There is no interruption has been done at x equal 2. I hope you understand. Look here for the last question. I think it's so easy. What value should be assigned to g of -1? What is the meaning of this one? What is the value of g of -1 supposed to be such that the function continuous at x equal -1? Look here, I've cleared first to make you understand. Okay. Here at x equal -1. Line. Here at what? -1. I know from the definition of continuity at x, for example, x equals 1, what is the condition must be satisfied? Limit f of x when x approaches to -1 from left equal limit f of x when x approaches to -1 from right must be equal f of -1. Clear? Since I know limit f of x when x approaches to -1 from left is what? As you see, I approach from left, go with the curve until I reach above, then take the value of y, which is 0, what? 1. So the limit from left, 1. The limit from right, by the same way as I approach from right, go with the curve until I reach above -1, take the value of y, it will be 1. The function be continuous at x equal -1, so f of -1 must be equal what? 1. That is the condition. So f of -1 supposed to be 1, such that the function continuous at. Okay. He asks you, I know the function is not continuous at x equal -1, but I ask you, what is the value of f of -1 should be equal such that the function continuous. It must be equal 1. Here, clear, first all. And let's solve that next question. Question number 2. Here he asks you, let f of x is a piecewise function which is defined by two rules. Which is defined by what? Two rules, as you see. Look here. That is rule number 1. I replace by the value of x in x squared minus 1 when x less than 3. And replacing this to the second rule, 2a x when x greater than or equal 3. Find a value of a so that the function is continuous using the definition of continuous. Justify your response. Look here. This function continuous, everywhere it means it is continuous for all of the values less than 3, greater than 3, and also at 3. I use the definition of the continuity here at x equals 3. This means if this function continuous at x equals 3, this means limit f of x when x approaches to 3 from left equal limit f of x when x approaches to 3 from right equal what? F of 3 itself. I have to get equation, okay, in A. By solving this equation, I will get A. I use this part of the definition of the continuity. Sorry, here this part, okay, which is what? Limit from left equal the limit from right. Limit f of x when x approaches to 3 from left, it means less than. I have to replace in this rule. It will be what? 3 square minus 1 equal, replace equal the limit of f of x when x approaches 3 from right. I have to replace in this rule. It will be equal what? 2 multiply a multiply 3. Implies this one 9 minus 1, it will be 8. Find the result here. Okay, equal what? Here 2 multiply, it will be 6a. Solving this equation, divide 6 and here divide 6, implies a equal 8 over 6. Equal what? 4 over 3 in the simplest form. I think it's so easy. Every time I use this condition, limit from right as a limit from left. To get equation in the variable, okay, by solving this equation, you will get the value of this variable. I hope you understand everything, okay? Let's solve the following question. Clear first all of the drawing. Here, please read the head of the question. He asks you what? Look with me, because let f be the function defined by the following rule. As you see here, that is the definition of this function, okay? Okay, defined by this rule as you see. Okay, here for what value of x f not continuous, use definition of continuous. This, as you know, this function before, look, I'm sorry, this function for all of the values less than x continuous, because it is a sine function which is defined on its domain all real numbers, so it is defined also for all of the values of x less than 0. This function continuous on its subdomain. This function continuous on its subdomain, and here also continuous in its what? Subdomain. So what is the rest of numbers? We have to discuss the continuity. Add 0, 1, and 2. Understand how to do like this one? Look with me here and here. Okay. Here I have to add x equal what? 0. Here x equal 1, x. I have to discuss by this way. Discuss the continuity at the values of x at which we define the function by different way, before it and at it and greater than at 2. What are the three conditions? F of 0, three conditions. Have to find the value of, okay, limit f of x when x approaches to 0 from left, limit f of x as x approaches to 0 from right. F of 0, I have to search for the rule at which x greater than or equal or less than or equal from here. So I have to replace here, it will be what? 0 to power 2, it will be 0. Okay, that is the first one. Limit f of x when x approaches to 0 from left, it means left, it means what? Left, it means less than x less than. Okay, I have to replace here in the first rule sign 0, it will be 0 as we solved it in the session. Okay, limit f of x when x approaches to 0 from right, x more than, right, it means more than, x greater than. So I replace in this rule sign 0 square degree, it will be 0. Since the three values are equal, in this case continuous, the function continuous at what? At x equal what? 0. I have to discuss the continuity, but I use different color. Wait. Different color used was red. Okay. At x equal 1, please focus. By the same way, f of 1, limit f of x when x approaches to 1 from right, limit f of x as x approaches to 1 from left. As I told you, when we find the value of the function, I have to replace in the rule at which we have equal. Okay, where is equal? Here with equal with 1. So I replace here, it will be what? 2 minus 1. I have to replace each x by 1. Limit from right, it means bigger than. Bigger, x bigger than 1. I have to replace in the third rule. It will be 2 minus 1, it will be 1. From left, it means x less than. X less than, it will be what? 1 to power 2, it will be 1. Since the three values, as you see here, are equal, so f continuous at x equal 1. I have to discuss the continuity. Up to now, the function continues on all of the real numbers. But here we have to discuss the continuity at 2 to be on all of real number. But if it not satisfied all of the three conditions at 2, so the function not continuous at 2. F of 2, limit f of x when x approaches to 2 from left, limit f of x when x approaches to 2 from right. Here, f of 2, I have to replace by the same way in which equal. So it will be 2 minus 3. It will replace here. It will be negative. Limit f of x when x approaches to 2 from left, replace in the rule in which the values of x less than 2. Here, x less than 2, replace it will be what? 2 minus 2, it will be. Since we have different value, that the three values must be equal. So in this case, we write what? F is not continuous at x equal what? I hope it's clear. But you have to know which rule I have to substitute, in which this value included in its subdomain. This is called what? Subdomains. Okay, here, look with me. When we say, as you see here, f of 1 I have to replace in which rule? In which rule at which x equal -1, greater than or equal. I have to replace in the rule such that the values of x included in the sum total. When I say here limit f of x when x approaches to 1 from right, I have to search for mean more than 1, more than 1. X more than 1, where here less than 1, here more than what I have to replace in the third. That is the way you have to think of when you substitute. I hope it's so clear and easy for you. Okay, wait, clear all of the drawing. Then let's solve the last question. It's very, very, very important. Look here with me. He asks you what? Limit f of x when x approaches. Look here. Look with me. Wait. I'd like to make it here. Wait a minute. I think it's clear now. Yes, yes, it's clear. To answer all of the question. Here, as you see, I ask you what? Focus with me, please. Very, very important question. Here, use, as you see, look with me, okay? Use the graph of f of x shown below to answer questions. Look with me here, as you see, limit, oh, I'm sorry. Look here, limit f of x when x approaches to -2 from left. Where is -2 on the curve? From left? Okay, from left. Go with the curve until I reach to above -2, then take the value of y, it will be 2. Limit f of x when x approaches to -2 from right. As we approach from right, go with the curve until I reach what? Above 2, then take the value of y, it will be 2. Since the behavior from left as the behavior from right, so limit f of x when x approaches to -2 exists, and it will be like them too. F of -2, as you see, it has a hole. Look here, it has what? Hole. As you see, not bold like this one. I write what? Undefined. When we talk about the value of the function and from the graph, if it has hole, only hole at it, so the function undefined. Focus with me the last question. It is very, very important. Okay, draw all of that. Drawing. Clear all of the drawing. The last question. Wait. Here, what is the last? Oh, what I don't have. Here, I read the question and the answer on the graph. Is f of x continuous at x equal -2? That is the first question. Second one, why or why not? If it is continuous, tell me why. If it is not continuous, tell me why. If it is not continuous, state the type of discontinuity and explain why it has the type of discontinuity. How many questions? 1, 2, 3. Okay, 4 questions. Look here. I have to help you focus with me. Very good question. Look here. You ask me here at x equal negative to the function continuous or not continuous. As you see, it's one of the cases that we were talking about it. It has hole. So the function, since the function undefined, so it is not continuous. F is not continuous at x equal what? -2. Why? Has hole, because it has what? Hole. It has what? Hole. So the function continuous or discontinuous, as I told you, discontinuous. F has removable, removable, what? discontinuity at x equal negative 2. Why? Because it has what? Whole. As I told you before, we have two kind of the or two type of the discontinuity. Removable discontinuity at whole or gap. Non-removable at jump or at what? Unbounded behavior. For example, to make you understand here, at 2, x approaches from left to 2, sorry, from right to, from left at what? 6. Here, as the function continuous or not continuous at 2, it is not continuous because it has what? Jump. So the function has non-removable or removable discontinuity. Non-removable discontinuity at jump. By the same way, at x equal negative 4, the function here, continuous or not continuous, as you see, it has unbounded what? Behavior. Okay, so in this case, the function discontinuous. What is the type of discontinuity? Non-removable. An unbounded behavior, which means at vertical asymptote, non-bounded behavior, so non-removable discontinuity. I hope you understand the lesson. Please watch the video many times to understand everything. Please study the very important notes which I uploaded on the LMS well to understand. Thank you for joining the session and for watching the video. Please study well to be ready for the quiz. Thank you.